This is section 5.6 in your student journal. It's on page 150 in your student journal. What we're going to be talking about today are inverse functions. Inverse functions undo one another. They undo one another. As far as from a graphing perspective, they are going to be reflections over the line y equals x. We need to know how to find inverses. The first thing we want to do is we want to remember that f of x is just the same thing as y. So if we see f of x, we want to just write it as y equals instead of f of x equals. The second thing that we have to do to find an inverse is we switch x's to y's and y's to x's. Wherever we see an x, we make it a y. Wherever we see a y, we make it an x. The third thing we do is we solve for the new y. And the fourth thing we do is we call it f to the negative 1 of x. This is the notation for the inverse of f of x. I will tell you that reading your textbook will not help you in this section. Our textbook does not do this the more involved way that we are going to do it. All they make you do is solve for x, and they call that an inverse. That is a very easy way to find the inverse. We're not doing it that way. We're going to go through and do it the way that you'll do it in pre-calc and calculus. All right, so once again, change f of x to y, switch x's to y's, y's to x's, solve for the new y, and then rename that new y as f to the negative 1 of x. Let's look at it. All right, so right here it says solve for the inverse of f of x. Then find the inverse of negative 6. The directions are going to look different for which you're going to do it. And it says do it this way on your homework. So when you do the book work, I want you doing it this way, finding the inverse of f of x. And then I'm going to put those solutions on Canvas so that you understand the way they should look. All right, so here's our first problem. Here's our original. We want to find the inverse. So f of x is going to be written as y equals. My next step is wherever I see a y, I change it to an x. Wherever I see an x, I change it to a y. I'm trying to solve this for this new y. So I'm going to go ahead and add 1 rather. I'm going to divide by 2. And so now I'm going to have y equals 1/2 x plus 1/2. And then the last thing I want to do is I want to rewrite this as f to the negative 1 of x equals 1/2 x plus 1/2. This would be my inverse. I also want to find f to the negative 1 of negative 6, or the inverse of negative 6. So if I plug in negative 6 into this, all that means is I'm just going to plug in negative 6 right here. Half of negative 6 is going to be negative 3 plus a half. Negative 3 plus a half is going to be negative 2.5. All right, I'd like to show you what this looks like. I'm going to use Desmos instead of the graphing. Yeah, I'll use the graphing calculator since we're under the dot cam. All right, guys, here's what I want you to look at. What these inverses are actually doing. So I'm going to put in our original function, 2x minus 1. I'm going to put in our inverse function, 1/2 x plus 1/2. Okay, I want to look at these together. I'm going to do a zoom 6. Here's my first function. And here's the inverse. Now, watch if I put in something else. I'm going to put in y equals x. Remember how I said at the beginning that inverses should be a reflection over the line y equals x. Can you see how that's a reflection over the line y equals x? I also want you to look at the table. When I look at the table of values, I'm going to check this. The inverse of negative 6. So here's where I put my inverse function. The inverse of negative 6 is negative 2.5. Something else I want you to notice. Look at this one. When x is negative 5, I get negative 11 on the original. If I look at the inverse, when I look at negative 11, I get negative 5. Do you see how all the x's and y's switch? Let's go up here in the positives. It'll be a little bit easier to look at. All right, so let's look right here, for example. So if I see the point 2,3 for the original function, I see the point 3,2 on the inverse function. Because here's my x, here's my y, now here's my y, here's my x. That's what happens with inverse functions. All right? Let's look at another one. Here's 5, here's 9. So what's the point I would see on the inverse function? If I see 5, 9 on the original function, what point will be on the inverse function? 9, 5. Scroll down. Look, 9, 5. Remember that's where I put my inverse function? One more, guys. If I see 4, 7, what's the other point we're going to see? 7, 4. There it is, 7, 4. Okay? See how it looks? Here's the original in blue. Here's the inverse in red. And there's the line y equals x that we reflected over to get that. Okay. So we've got that done. Now let's do this one. So my f of x, I'm going to write it as y. So now y becomes x becomes y. I solve for my new y, so I'm going to take this y over here to make it positive. And I'm going to go ahead and take the x over here. Just did 2 steps in one there. I have to solve for this new y. How do I solve for it then? I have to take what? Square root. If I take the square root of an equation, I must put plus or minus in front. And so here's what I get. So here's the inverse function. I want to change this y to f to the negative 1 of x. So there's going to be my answer for the inverse function. Well, maybe not function, actually. I shouldn't say function. And I'll show you why I should not say function. I'm going to put this in, my original function that I had. Guys, you should know what that looks like. What does that look like? Before I graph it, it is a what? Upside down parabola, right, and it's been shifted up 1 unit. So 1 minus x squared. Okay, now I'm going to put in my inverse function. Now this is actually two parts to it. So I have to put in the square root of negative x plus 1, and I have to put in negative the square root of negative x plus 1. So watch. Here's the original function. Here is the inverse. Is this inverse a function? Did you guys learn in Algebra 1 about the vertical line test? Some people are saying yes, some no. Okay. The vertical line test says in order to have a function, a vertical line can only touch the graph in one spot. See how on the parabola, a vertical line only touches it in one spot? But look at the inverse. Is a vertical line only touching it in one spot? It's touching it in 2 spots. So this inverse is not a function, but the original was a function. See what I'm saying?
Do you mean it's like touching in 2 spots on the y-axis?
Yep. Or anywhere I put a vertical line. If I put a vertical line right here, it touches it twice. Let me put in this line, and you can see how it's going to be that reflection over y equals x. See See how here's my original and it's just a reflection over y equals x? Okay. So the last thing we have to do is find f to the -1 of -6. So plug it in. -6 is going to be +6, plus 1 is 7. So that's going to be plus or minus radical 7. That's what I get when I plug it in. What questions do you have? All right. So I'm going to skip this first step now because we know f of x is y. So f of x is now going to become x because it's a y. X is going to become y. I have to solve this for y, so I'm going to have to bring this over. To solve this, I'm going to take the cube root. So this cube root of y cubed is just y, but I'm going to now call that, it's y, but I'm going to call it f to the -1 of x. And this is read as the inverse of f of x. Here's the inverse function. All right, guys, let's talk about how we would know this is correct. Let's do it without the graphing calculator this time. Here's my axis right here. This is a cubic function that's been shifted up 2 units. It's going to look like this. All right. Now I'm going to look at my inverse function. This is a cube root function. What's the shift to the what? Right 2. So it's going to go like this. And I know what that cube root function looks like. It goes like that. If I did the inverse correctly, it should be a reflection over the line y equals x. Is it? Yes, it is. Are they both functions? Yes, they are, because they pass the vertical line test. So therefore, I know that this is correct. Now we have to find f, the inverse of f of -6. You guys tell me what that's going to be. Which is it? Anish?
So do they always intersect at the y equals x? The inverse and the regular?
Well, they wouldn't always, but a lot of times they will. I'm just thinking of inverses in general. Like if I had a parabola like that, the inverse would be like that, and those two would not intersect at all. So I was just trying to think of a case where they wouldn't. So, but these would, yeah, a lot of times they do. So just remember what these inverses actually do. They undo one another, right? So therefore, when I look at the x's and look at the y's, they should have that consistency that we talked about, where if we see a point xy, we're going to see yx on the other one. Just want to show you that. All right, so we're going to look at these. It's just like the way I just graphed it, but I wanted to show you the table of values so that we don't have to create the table of values. So there's just a check of our graphs. I didn't graph y equals x this time, but that's okay. So now look at the table of values. So like I know the point -6, -2, right? So -6, -2, that's going to be on the inverse function. So what's the point that's going to be on the original function then? -2, -6. You see what I'm saying with that? Okay. All right, let's keep going. So find the inverse of the function, then graph the function and its inverse. I've kind of been doing that all along, but now we don't have to plug in a value. All right, so you guys go ahead now and find the inverse of this. This is something you want to be able to do without the graphing calculator. So did you guys get it? The original has a slope of 2, y-intercept of 0. The inverse has a y-intercept of 0, a slope of 1/2. And I can see how they are reflections around that line y equals x. All right, let's do the next one together. So here's my y. I'm going to change it to x. Here's my x. I'm going to change it to y. When I take the square root of both sides, what do I have to put in front of here? Plus or minus. So this is going to be plus or minus the square root of x equals y. So we're going to graph the original. The original is just y equals x squared. I know I have 0, 0, 1, 1. I've got these points here. 2, 4. Just trying to get a fairly accurate graph. Okay, now I'm going to graph the inverse. So if I plug in 0 for x, I get 0 for y. Plug in 1 for x, I get positive 1 or negative 1. Plug in 4 for x, I get positive 2. And I also get negative 2. See how that y becomes x and x becomes y? And that's the way it's going to look. So we've got the original in black and then the inverse in red. Is the inverse a function? Yes or no? The inverse, is it a function? No, it does not pass that vertical line test, so it is not a function. The original one was, but not the inverse. All right, good. Okay, let's go down here now to the bottom. It says determine whether each pair of functions f and g are inverses. Explain your reasoning. What did we say about having inverses? X must become what? And y must become x. All right, so we're going to see, does that happen? Here's all of our x's. Here are all of our y's. Here are all of our y's. Here are all of our x's. What do you guys think? Yes or no?
Yes.
Look closely. What did they do to us?
Oh, they flipped the negative sign.
Yeah, just this very last one. I think it's kind of silly, but yeah, it's not because of that one right there. So no. Yeah. And if we just made that a positive one, then it would be yes. But there we go. And then what about this? Here's our x's. So the x's did become the y's, but did the y's become the x's? No. So this one's an obvious no. This one they just tried to trick us on. Okay, questions? Feel like you can do this? All right.